In 3DMed project, we have tried to streamline the design procedure of patient-specific medical devices by means of optimizing several algorithms and software packages in the form of semi-automated software suite. Implantable medical devices, orthotics and prosthetics, and surgical guides are the main targets of this work. Medical images are used as the input of the software platform, and 3D printed patient-specific medical devices are the final output.
One of the goals of this project is to enable the production of patient-specific medical devices without the need for patient to be present during the design procedure. So here we have started our design based on the patient's anatomy, which is characterized using medical images. And then we use finite element modeling in order to investigate the mechanical reliability of these designs under different physiological loading conditions. Then we use topology optimization to reduce the weight and increase the comfortability of these designs. Finally, thanks to the additive manufacturing techniques, we are able to produce these devices with such complex structures in different materials and with high quality.
At Vigo, we make patient-specific orthotics and prosthetics. So the patient comes to us with a prescription from the hospital, and then we get started. Normally we make the braces with the conventional way, like this scoliosis brace, but within the 3DMed project we made also a 3D printed version.
A big problem in our residency program is how to train our residents to be an orthopedic surgeon. And a very delicate surgery within the hand and wrist is the Brunelli, in which we perform a ligamentoplasty of the carpal bones. For this procedure, we have to drill the K-wire into the carpal bone, which is really small. And you can imagine, if you have to re-drill for 3-4 times, the bone will collapse. So what we ask our CT specialist to make a 3D image of the carpal bone. We make a patient-specific guide, and we perform the surgery with the patient-specific guide. What we did here, we did the surgery at the wet lab at the Erasmus University. We bring it back again at the Reinier de Graaf Hospital, and we ask our CT specialist to perform and make another CT scan.
At Dutch Ophthalmic Research Center, we develop and produce instruments for ophthalmic surgery. We focus on instruments for vitreoretinal surgery and for anterior surgery within the eye.
And in the 3DMed project, we developed also 3D printed instruments together with other partners in the project. One of these is a trocar cannula together with a trocar valve, and this instrument is used to insert other instruments into the eye to perform surgeries. Then we also developed a vitrectomy mechanism with a polyjet technique that uses different material, and then you can have one print without assembly steps.
This is the XOL ankle brace. The XOL ankle brace is a 3D scan to 3D print product, and it prevents you from spraining your ankle. We worked together with the 3D partners and did some research on the padding foam. Padding foam is the layer in between the 3D printed material and your skin, so it's directly in touch with your skin. Besides that, we gave some input data on the image acquisition.
It has been a great privilege and opportunity to work with all these nice partners in this exciting project. Together, we have been able to achieve so much in terms of the deliverables that have been delivered and outputs that have been established, and the platform that is going to transform the 3D printing of medical devices in this region and beyond. I would like to thank the joint secretaries, the partners, the observer partners and territorial facilitators for all their contribution and dedication.